Hey everybody, welcome to the stream. Hey Michael, welcome man. It's good to see you. Uh, if you guys were here beforehand, you saw me experimenting a bit with a couple different models. I want to try, so I can run the models locally, but when I run them locally, I was trying to quantize the memory to keep the memory small on my video card. We can talk about what that means. And I apologize about the dogs. Say hello to my dog. I will. Come here, Indy. Oh my goodness. Oh, she is having a hard day today. Sunny, who is pulling on my headphones right now, is terrorizing her. So my wife and daughter are getting ready to travel, and Sunny and Indy are they're a little bit worked up this morning, and Sunny is a little terror, and so she chases Indy around the house. So we're trying to break her of her puppy habits. But anyway, today I wanted to talk about how good are these local models. That's fine. You can trap Sunny in here. Come here, Sunny. 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 Come here, sweetie. Sunny. Hey. Oh well. I won't get too distracted on that. She'll come over here eventually. But I wanted to see how the different size local models are. And if you guys saw before the stream, I was experimenting with the local model, and I was running the same model we're running right now. If we go take a look here, it was the Qwen 3.5 9 billion model provided by Qwen. And I'm not logged into my Featherless account on this browser, so we can't do a preview chat with it. But this is a dense model designed for coding, really good. We can see I was using this is an example of a model that I wanted to use, and we'll try this model out too. Like these Quithos and the Quable and Quopus and all of those different ones, where they basically take Qwen and then they use it against Claude's Mythos or whatever to try and get similar reasoning. So I'm curious about that too. But we can see here there's a couple of things to see when you go to Hugging Face, right? First of all, let's go back. First of all, on Hugging Face, and I'm not signed in. I'll show you something with a signed-in browser for the Qwen. But the first thing you want to do is you want to understand your video card and how big your video card is. My video card is it's a 12 gig laptop video card. So I do all my streaming from a laptop. And so I can get about a 9 billion parameter model that's been quantized. That's an important piece there, right? Is the quantization. So I can get about a 9 billion parameter model that's been quantized into memory. There you are, little one. Hi. Oh. Here's Sunny. She's not happy. She's been locked in the room with me. She wants to go hang out with Indy. Hi, sweetie. Yeah, I know. You're having a hard time, huh? I'm going to go let her out really quick. I'll be right back. Okay. Oh, no, that was a mistake. Good catch. That was a mistake, but luckily my daughter caught her. She's a puppy, so she still likes to run, and the back door was open because they were loading the car. But she's a sweetie. She just has a lot of energy because she's a puppy. Anyway, when we pick a model, you can sort by all sorts of stuff. My recommendation is to come over here and just look for the amount of parameters that you want. You can also do, you know, different things here. The reality is, if you sort by trending, it's going to be coding models at the top anyway, all coding models. And then you can do other stuff if you understand. Like if you're running it on Apple hardware, this MLX can help if your Ollama supports it. So there, you know, there's a bunch of different filtering things you can use. Hey, you alternate. Good morning. And Sky Zero, I saw you say hello a while ago, and I kept meaning to say hello, and I just didn't. So what you're looking for typically is like a GGUF. These are quantized models. These aren't the full-size model. So like if we look, this 16-bit, this BF16, what this means is this is the full-size floating point model. And you can see that the full-size floating point model is either 18 gigs, well, right around 18 gigs. There's no way that's going to fit in my video card memory, and that's going to lead to a bad experience. It is growing, and I appreciate you guys showing up. So then the next thing you can do is you can start looking here. In the past, what I used to do is I used to grab like the 8-bit, right? When you're coding, 8-bit is probably not what you want. Like you want it if you can, but when you're coding, you're looking for a context window. And so on a 12 gig card, if I go with this 8-bit quantization, that's going to fill up my memory so that I'm not going to get a lot of context. So usually I go with like a 6 or a 5-bit quantization. And you can get to those here through the files and versions on Hugging Face, and then pick the quantization that you saw back there. Let me show you guys. It's because dogs, maybe I do need to use the dogs to help grow my grow my popularity, right? So let's take a look at so here's the same model we're running. Actually, we aren't running the uncensored aggressive, and that may have been why it got stuck in the loop. Like sometimes these uncensoring, but this was one of the top models when I was searching. But if you look, I've got a user created and I've set things up so it knows that I've got, you know, the RTX 4080 mobile with 12 gigabytes of RAM. It also knows that I've got 64 gigs of RAM, and it knows about my processor. So when I look at this same chart, it's telling me you can't do the BF16. It's not going to fit, right? With the 8, it says you could probably run on your hardware, but what it really means is you won't get good context, right? At six bits, it'll run, right? So if you create a Hugging Face profile, you go to any of the GGUFs, you're going to get this table that's going to tell you, hey, this will probably fit on your hardware. So that's one thing that I recommend doing. I'm not signed in on this browser. I don't sign into things on this browser because I don't want to accidentally leak keys or things like that. But once you've got that set up, you need to run a tool to get things to work. I use Cobalt CPP. It's a wrapper around Llama, and it has some other stuff built into it. I like it for Windows. So when I launch this, it's basically a wrapper. So it's telling me that it's got, you know, different things going on. This is going to be hard to see, but if I increase the size, then the UI gets messed up. So please bear with me. The back end, right? On the back end, there are different things. So CUDA is for NVIDIA GPUs. Vulkan works, right, is slower, but it works on different GPUs. Otherwise, you can go CPU only with GGUFs. And so you've got all these choices. I always use CUDA because I've got an NVIDIA card. So my my GPU ID is 0. I've got another built-in card, so if I were to swap to 1, it would swap to my other video card. There's a bunch of different things here that you can learn about. One of the things to know is like the GPU layers. I typically leave it set to -1. And this allows me to, or this allows the model to tell Ollama how many GPU layers. In a GGUF, you can unload some of the layers to your CPU, and you can keep some on your GPU. And so to do that, you can specify this. So if you want to run a much bigger model, you can tell it, yeah, I want to run like 20 layers on my GPU. And there's a lot of tweaking to go around with this. I typically try to just keep everything on the GPU, so I leave it at -1 and it just loads everything. So that's an important thing to know. The launch browser, it includes a chat with it, with the Cobalt CPP. Context shifting is a way to allow, so like your context has a window that stays in memory, but with context shifting, you can actually get much larger contexts by allowing the context to shift. Flash attention is something that's specific to GGUF models. And then here, if I set this to the 144 for my context size, and I load, this model, you can see right now it's going to load all 33 layers on my GPU because I've told it to be auto. So it gives me information about that. On my context, if I try to go all of those 144K context in memory, it's going to have to offload some of that off of my GPU. That may not be a problem, but if you're looking for speed, one thing you can do is you can quantize your cache, right? And so what quantization means, just kind of like a high level overview of it, is when models are trained, they use a floating point 16 vector for the for every token, right? So token probabilities are stored in 16-bit vectors, which means there's 16. It's an FP16, right? As soon as you start quantizing, what happens is, like if you go to a Q8, what happens is you've gone from a 16-bit floating point to an 8-bit, right? Essentially chopping half the memory off is a way to look at it. And that's the same way to kind of look at the quantization of the models, right? So like if you're at a Q4, you've got 1/4 the size, and there are different ways to do this. So that's not necessarily true, but but in general, when running things locally, you can think of like the size of the vectors as being chopped. And there are different ways to do that chopping, so that some vectors that are more important stay the full 16, and other ones that are less important may to go to 3 or whatever, right? There are different ways to do it to achieve different types of quantization that achieves different types of perplexity. When you go from a Q16 or from a F16 to a Q8, the perplexity increases a little bit. And we can probably see a lot of times with these models, they'll include perplexity numbers here. Let's see. So 1 million. So this GGF has a yarn with 1 million token context baked in, which is 4 times. So you could, like, if you're running this locally, and this is part of the reason why you might consider running something locally, because I'll show you some stuff about featherless, right? But they aren't showing. A lot of times there's graphs on Hugging Face, about how the perplexity changes based on the quantization. And typically, the perplexity changes for sure when you go from a full 16-point floating point, floating 16-bit floating point number down to a Q8, and sometimes you might go to a 5.1 or a 4. I was running a 5.1 quantization, which is the quantization that I was talking about. That it's basically a Q4 quant, so it's 1/4 the size, but it goes and it uses some information to determine, which of the vectors is most important. Those may stay as a 16 or an 8, and it may chop some of the less important ones down to a 4 or a 3, right? Like that, kind of a high level way to look at a 5.1. So by doing a 5.1, I was able to get 144K context into memory. It fit all within my memory, but it was slow, and I was having some issues running it with streaming going on. So there's a whole bunch of stuff you can do here. Cobalt has built-in network support, right? Like for the browser and things like that. You can control what port it loads on. You can give it remote tunnels and do all sorts of nice stuff with it. You can even set up, how many users are allowed to connect and all sorts of stuff like that. Horde is like a weird chat, not weird. It's a chat thing. I don't really understand it. That's why I said it was weird. You can set up image gen if you really want to. You can set up audio gen. You can set up administration. And then I've extracted the Cobalt stuff to make it faster. And you can even analyze your GGUFs. I'm not going to do that because it takes a long time. But you can analyze it and it'll give you more information about it. Lots of good stuff in this tool. Lots of other tools out there that will do the same thing. Very, very powerful. Just, spend some time learning your tools and they'll work really well for you. I'm not going to launch this because I don't want to. Actually, I can, right? So let's launch it, right? So we're using 144K context. We're using a 9 billion parameter model. And on the context, we've done a Q51 quantization, right? So let's bring up my task manager here. And we're looking at my GPU right now, my NVIDIA GPU. And so as soon as we launch this, what we'll see is we can immediately see the RAM usage kick up. So this first jump was loading the model. The second jump was preserving memory for the context. So we can see using those settings, I'm able to fit the entire model into my video card. This is going to give me the best performance that I can get. There's some shared GPU memory, but I'm not using it. So I'm able to get, within 10 gigs. So I could probably go to like a Q8 quant and get the same context, and that might be okay. So, there's some tweaking that goes on with this stuff when you do it. But useful to know. Do I think the new Mythos model was really that good? That is a good question. So what do I want to say about Mythos? I think Mythos scared some people, is what I want to say. I think it became scary because of the ability to attack unsecured, right? Like the attack abilities of Mythos and Fable were better, much better. The reasoning model allowed it to attack better. And because it could attack better, it gave people the ability to attack we're not good as humans at securing our stuff. There are very few things that are really, really secure. Um, and because of that, having a model with the capabilities to attack was probably the reason that it was taken away. I don't know much more beyond that. Um, yeah, um, sometimes I try different models for the same task, but I don't feel like the models have improved that significantly. Does any? No, I don't feel like the models have improved that significantly. I think the local models have. So if we look at this model that I'm running right now, we can see it's a 9 billion parameter. One thing, so I am not sponsored by Featherless. This is not an ad for Featherless, but I do want to explain it. So it may come across a little bit as an ad for Featherless. I like Featherless because of a lot of reasons. But one of the biggest reasons is it's fairly cheap. I'm not going to say prices and stuff like that. You guys can go to their site and look it up if you want to. But it's fairly cheap for unlimited tokens. And the way that they do that is they use a concurrency cost. So when you go to a model on Featherless, it gives you a whole bunch of information. So like Qwen359b has a vision, which means we can feed it images and it'll be able to tell us stuff about it. It has a concurrency cost of 1. On the plan that I'm on, I can have up to four concurrency running at the same time, which means with Qwen 3.59b, I could have 4 agents running that model for this concurrency cost, which is a good thing to consider. The model size, it's a 9 billion parameter model. They're loading the FP8 quantization, which means we're running an 8-bit floating point precision here. So they're saying it balances speed and quality. Really, it helps with their memory usage, right? They've limited my context to 32K. That's a little bit frustrating, but we'll use what we use. We could call tools, which means it's MCP enabled. This was released in February, right? And we get we get all sorts of information about it. We know it's a transformer. We know it's using open weights. And this WARM means that it's loaded into memory, so you can run it right away. If that doesn't say WARM, then you might have to ask them to load a model for you. You can have them load any model off of Hugging Face. In my experience, you get it within like an hour or two, and it's ready to go. So if you want to try out a model on Hugging Face, they'll open it for you. If it's not a very popular model, this concurrency can go up to 2 or 4. So that's something to be aware of. And there's some other models that are really, really big that will run for. We'll see those later when we get into like DeepSeek and GLM 5.2. But yeah, this is kind of this is the lore, right? The backstory to what we're doing today. So I want to compare a couple of things. So we've got our Qwen 3.59 billion parameter model. And with this model, you know what, let's give it a fresh, context. Like, it's not fair that it's where it is right now. So let's go ahead and just give us a new chat. We're using the Qwen 9b model that we've got. Actually, let me show you guys how you get here too, right? Let's paste that in so that we've got it. We're set to agent. We're on the Qwen 9b. We can configure tools that it can use, and all of that stuff. But let's say you want to add your own tooling to, and we're in Visual Studio today because doing this in Gemini is not easy. Visual Studio allows us to do it really, really easily. What we can do is we can go here to the model selection and we can go to manage models. And so you can see here that our Qwen, let's go ahead and we'll go ahead and pin that one. But to add a new model, all you have to do is go here, and you can add anything, right? So if you've got Google, OpenAI, OpenRouter is a competitor to Featherless. I used to use OpenRouter. I moved to Featherless mainly because of pricing. If none of these work for you, you can fire up a custom endpoint, you name it, and then, so, you know, this is our test. And then you give it an API key. If you've got an API key, if you don't, then don't. Then here you just pick chat completions. At this point, it's going to bring up, you know, the different things here. So, you know, we can see all of the various parameters that we can tweak. We're going to take this one out because we're just going to do that. So there we go. But yeah, this is how you would add new models. So this is our Qwen. The identifier is, it comes from here. So this is the ID to Featherless. So they've got a nice little button to copy it. So I copied it and I pasted it right here. I gave it the name that I wanted. You know, we can probably clean this up. We can call it a Qwen 3.5, 9 billion parameters, right? The endpoint is the chat completions because I told it was chat completions, and you know, we've got tool calling and vision on it, and you know, we're good to go. So that's how we set that up. What I want to do is I want to just put it through its paces. So let's run. We'll get. I thought I had a way. No. Scratchpad. I mean, what we could do is we could just go here, and just go, and here we'll just add a new file. Actually, I could just press the button, can't I? New file. This will be our test prompts for AI, and this will be a text file. Great. So here's our test prompts. So the first prompt we have is, are there any components that could be changed to signal forms? Another prompt that I want to run is, describe this project for me. Tell me about the libraries used, and also tell me how modern it is, right? We're going to give it two things to do here because I'm very, very curious. So we're going to start with this prompt, and then we'll go into the signal forms prompt. And these will be the two prompts that we're going to use. And we're going to compare these two prompts across different models because I'm curious about it, right? And we'll get a new chat every time so that our context is free every time. So here we go. Here's our first one. And we can see that right now we're connecting to the model. And I'm very curious to see what we get out of this model. This is a 9 billion parameter model. The model itself, we've got the Angular, we've got the So we're in the same state we were in 2 weeks ago. I haven't changed anything. So we've got the Angular skills. We've got other skills that we've written. We've got the NX MCP stuff loaded. So we're getting some interesting stuff here, like this LES with proper line ranges. Euler version more carefully. This just might be the tooling picking some stuff up and cutting stuff off. So this is a 9 billion parameter model. This is a model that if you've got a decent graphics card, or if you're running it on like Apple, and you've got a good amount of memory, you could run this model locally, right? So we can see overview. It's saying full stack dynos. This is a modern full stack monorepo demonstrating contemporary web development practices. Here's a detailed breakdown. Great. So it's picked up that we're on NX 22.7.5. Let's pop open our package.json. So we're gonna close this. We're gonna close this. We're gonna close a lot of this just because. So our NX here, is it picking up the proper version of NX? 22.7.5, we're good. The backend is Nest.js 11 with GraphQL, Apollo Server 4. That's correct. I know that's correct because we're still out of date on Apollo Server. Angular 22 with standalone components. That's a good pickup. Postgres with Prisma 7.8. It picked up the Postgres from our README. I'm looking for our Prisma 7.8. Package Manager PNPM, that's correct. Node this via Volta. That means it read the package because we can see down here that we're using Volta. So we can see it's picked up 11.1.2 through Volta. Perfect, right? So we've got a table of that information. Front-end Angular, we're using Angular Core 22.0.1. That's correct. Animations, forms, router, Apollo Angular. We're using NGRX signals at 21.1.1. I believe that's correct. That is correct. So we're using the NGRX toolkit at 21.0.1. NGRX toolkit. Excellent. Oh, it's Angular Architects. At Angular Architects, NGRX, there we go. So it looks like it's picking the stuff up correctly, Zod, mutative, all of that stuff. Just go flip some burgers. Oh, it's interesting, right? Because there's stuff that AI does well, and there's stuff that AI doesn't do well. Some days I want to go flip burgers, I'll be honest, but I felt that way before AI. So thanks for showing up, Aurelores. Tailwind CSS correct, Post CSS correct, Daisy UI correct. All of this is correct. Cypress correct, Jest, yes. We're probably going to pull out NGNeat Spectator. Enough said about that. If you guys want to know more, go look up the NGNeat stuff. But I don't want to get into controversy. But AI does well. It makes me able to work 3 jobs at the same time and make 13K euro this month. Wow, that's pretty impressive, man. That's really impressive. I made what the average Italian makes in 1 year in about 2 months. That's really cool. I'm impressed. That is very impressive. So how modern is this? It's extremely modern. Saying we're cutting edge as of mid 2026. Fascinating. Very modern features. We're using Angular 22. We're using standalone components. No ng modules. signal-based reactivity, built-in SSR, and zoneless architecture, correct. Nest.js 11, that's correct. NX22, all of this is correct. Modern state management, we're using signals. Yep, we're using signal store. It's interesting that it's calling this Angular's modern signal-based state. So it's picking up NGRX toolkit as being modern state management. Way to go, Michael. You guys picked up, you guys hit modern Angular signal-based state. So we're using with mutation, RX mutation, with call state, with errors. Okay, so these ones right here are not NGRX toolkit. These are ours. So there is something interesting here. Modern GraphQL, great. Modern tooling. Yeah, we're using PNPM. Volta. It should call out that Volta should be changed. That's one of the things I want to do is get rid of Volta on my machine. ESLint 9, ESLint 10 is not modern. ESLint 9 is not modern. ESLint 10, these ones I don't know. Mono repo is shared, yep. TypeScript, yep. Zod, yep. Mutative, yep. RxJS. Using JS Cutlery. I think we pulled out most of that, but not all of it. So we got a 9.5. Okay, so it is calling us out on some of our dependencies. Web components or quick. Interesting. This is very interesting because this is more of like a React style call out, I think, not really an Angular. So it says it's an excellent template. Great. So it thinks we did really good. Now let's see how well it understands Angular, right? So let's give it this prompt, right? And this prompt is, are there any components that could be changed to signal forms components in the project? That's all I'm giving it, nothing else beyond that. My AI also says everything I do is right and it's modern, but my projects are kind of garbo. Go get an obliterated model, man. They'll swear at you. They'll tell you that they hate you. That way you don't get the syrupy stuff. Using AI at work allows me to have more free time to contribute to Angular or read manga. Love that. Yeah, I use AI quite a bit at work. I spend most of my time building agents that I then turn around and use to build more agents that I turn around to build more stuff, right? So I'm still building, it's just differently. Vibe coded project, I don't have time at all. Because the project was vibe coded, all of your stuff is done. So again, this is a 9 billion parameter model. This is much smaller. Like if you go look at Claude or those, oh, look at that. So please try again. So the maximum context is 49,152 tokens. So we're gonna have to go fix this. We're gonna have to copy this. We're gonna have to go here. We're gonna go manage models, and we're gonna go edit this model. Open in language models. So how do I control? Interesting. So it's saying we've got 144K context size, which we don't want. Give me just a sec. I'm gonna put this on to be right back. While I click this button here. Oh, never mind. We're good. We'll go back to live. I'm curious if I come here and I open in language models. So we're getting 16,000 max output and 128,000 max input. Our context length is this. So if we subtract 16,000 from this, which I think we have to do, I think it's going to be that. So let's take a look after we make this change. We take a look at our models. Yeah, now we're at a 49K context size. So it is those two together. We want the 16K output size. Let's try again. So we've cut down on the amount that we get back. And already it's saying, based on my analysis, edit dyno component is already using Angular signal forms. And now it's having to compact the conversation a lot more. And this is the problem, right? Is that if we look at our context, we're using the entire context because we're reserving this last bit for the information that comes back. And so it's going to have to keep compacting conversations for us. Not vibe coded for me. This guy must use lots of AI. It's top contributor, not on the team over the year. I did a fix a doc. Oh, stuff that's not vibe coded by you. That's the other thing that that I think is an interesting point of discussion is code that's vibe coded by somebody not you is code that there's a potential they don't understand, you don't understand, and only the models understand it, and that's a potential problem. So there are some issues that could go on there, right? And this is taking a while to compact this conversation. I was gonna compare while this is going on, let's go take a look here, right? So this is the Qwen model that we're using right now. If we take a look at the trending Qwen models in the 7, so I've got it set to 7 to 9 billion parameters, right? So this Qwithos, the Mythos version of Qwen, is the most popular on Featherless right now. In this range. But if we look at all of these, they've all got a 32K context. Ooh, this one has a 4K context on a Mistral 7B. So we've got low contexts on a lot of these, and this is the problem with like not hosting it yourself, right? Is you're going to have a lot of these compacting. So it's still analyzing, and it'll probably take a while to go through all of this. Oh, we just crashed our JS service. That's great. Oh, wait, why are you changing files? Okay, so there's a problem. I asked it to fix a simple bug, but it got stuck for 5 minutes, so I had to do it manually. It takes ages to find where something starts and ends. Yeah. Sorry, no response. What? No, there was a response returned, but I've successfully converted the form components to signal forms. So let me provide a summary. Great. I've converted the form components in full stack dynos from legacy Angular reactive forms model and ng model to signal forms using the Angular forms signals. Oh no. So I didn't ask it to do this, right? I asked it, are there stuff? It decided, hey, you know what would be awesome is if I went out and made changes. Oh no. So text area component, good idea. Text input component, good idea. Inject ng control, no longer needed. So there's some interesting stuff here. So it did find, I did want to take a look at the text area component. And let's take a look at what it did. And we're going to reset this. Oh, hey. Love you, sweetie.
Love you. Bye.
Have a good trip.
Bye.
You guys have fun. Drive safe. But yeah, so let's take a look at what it did, right? So it brought in form and form field, okay, from signals, perfect. Inject ng control, I don't know that we need it. So it's bringing in form field and no op access or directive. Interesting, why? So ng control.control, form field is control, form field is control. So we don't need the inject ng control. Okay, so it messed up here. It tried, but it messed up, right? Because with this, it's creating its own control with a value and a disabled, which means we can't pass in value and disabled. So it tried, but it didn't work. I'm willing to bet that our text area component has the same problem. Yeah, not what we wanted. Bad choices, not good. So we could work with this, right? We've got some interesting issues going on here. We're like disabled, like we're getting some weirdness. And this is the problem with like smaller quantized models, is that you'll often run into these issues. So let's try a slightly bigger model from this and see what happens. So let's go ahead and go here. And we're just going to reset our workspace. So right here, we're just going to, what happened here? So we're going to discard these 3 files. So there we go. We'll go ahead and stage this file. That's fine. We'll commit it. We can use this. So AI is useful for finding vulnerabilities when you understand a repository internally. Some Angular vulnerabilities I found with AI. Others were found manually. And that's what I think is the biggest benefit to using AI is like a human context window is often much smaller than an AI context window, even at 32K context, right? And so it can look over a lot of things and keep a lot of things in its memory. And it may get things that are pushed higher in its memory because of how often they appear or how they appear in the code, which can help with understanding of code. I totally agree with that. You found multiple a week. AI is a powerful tool, but because of all of the hype, I expected to work 1 hour a day, but not all this mess. I agree with you, Ola. AI is great at amplifying. When it's amplifying amazing code, it is an amazing tool. When it's amplifying what it sounds like you're dealing with, it's a slog, right? So Qwen 9b, actually decent. I would argue that you could use the 9 billion parameter of Qwen, run it locally, give it 100K context, tweak things appropriately for the response and all of that, and you would be in a good place. I think you could do that. We're going to try and keep things into 32K. So when we look at this model, 49K is too big. So the next model, let's take a look at another model. Let's take a jump up in model sizes. So we're going to go to the 28 to 40 billion parameter model. Oh, let's turn off the 7 to 9. I was like, no, we shouldn't be getting. So at the 28 to 40 billion parameter model, we're starting to get some of the bigger models. So if we look, this is the Qwen, and this is a good model. This is the Gemma. Let's start with Gemma. Gemma is Google's OpenAI or open source AI. It's a dense model. So let's take a look at Gemma really quick. So Gemma is a 30.7 billion parameter instruction model, multimodal model developed by Google. It can process text and image inputs, generating text outputs, and features a 256K token context window. Unfortunately, we're at 32K context, right? So we can't take advantage of the full window. This is why if you could run it locally, you should run it locally because you could go to 256K. It is designed for advanced reasoning, coding, and agentic flows. Perfect. This is perfect for what we want, right? There's a whole bunch of information about Gemma here, right? Multimodal processing, meaning it handles text and image inputs, advanced reasoning. So let's, it's also 2 concurrency cost for us. It's quantized down to an 8. We've got a 32K context window. So let's go ahead and copy this. And let's swap over to the Gemma model. So we're going to manage models. And on our feather list, we're going to add a model. So it went ahead and added it. Our ID is that. We're going to call it Gemma 431B instruction tuned. Instruction tuned means reasoning. So we're going to say reasoning here. Right. And the URL is the same URL as up here. So we can copy this and paste that. It's tool calling. But here, if we go 16,000 output, then 16,000 is our input limit. Right? We're just doing back of the napkin math here. Let's go 32,000. Let's see if we get 32,000 context in and then 16,000 generated out. I think what happened here is we ran, like the reason we had problems here is we ran into the max. So I'm curious about this. So we've added our Gemma 4. So we're going to go ahead and say new prompt. We're going to come down here and instead of Qwen, we're going to say we want our Gemma 4. And we'll unpin this one. So there we go. We're now on the Gemma 4. We're going to start again using this to describe the project, right? So boom, describe this project, tell me about it, tell me how modern it is, right? Multiple requests. So it's already, we're getting text much faster. It's also better text, right? This is a sophisticated, we also aren't getting a lot of the reasoning. It's highly modern, usually cutting edge stack. So it's telling us already it's a CRUD system for managing dinosaur data. Yep, perfect. Okay, boom, we got a problem here. It's telling us Angular 17. Wrong. It's a key highlight. We're using signals. Yes, we are. We're using component store. No, we're not. We're not using component store. We took out component store. So those are wrong. So we're using Nest.js, great. Monorepo testing. This project is extremely modern. Again, it doesn't use current versions of libraries. It adopts the bleeding edge of the ecosystem. So we're using signals. Yep. It avoids ng module. Type-safe end-to-end. So it's picking up that we're using type-safe stuff and modern tooling. Great. So when we compare this to Qwen, right, like the 9 billion parameter model actually, I would say, did a better job here. Let's now give it this prompt. One of the things that I'm wondering about is, well, it got the same amount of output, so I'm not sure why we got this, but let's give it this same prompt and see what happens, right? Any components that can be changed to signal forms components in the project. And so now it's thinking about this. While it's thinking, right, we'll come back and take a look. I want to take a look at Quable, which everybody is saying is pretty impressive. So let's see what versions of Quable are up and running on Featherless, right? So here's the one that I was reading about that everybody said was amazing. It's the Qwen 3.5, it's Quable, and it's obliterated. What does this mean? So it's an MOE, so mixture of experts. Mixture of experts is an interesting way to do models. Basically, what happens is that each layer in the MOE, mixture of experts, is an expert in predicting the next token. I used to think about it like, oh, this expert's for science, this expert's for coding. It's not really the way it is. It's just that different experts learned how to generate tokens based on different things. And it's not necessarily that they're experts in fields, but they're experts at guessing the next token based on different, parameters. We may not know what those parameters are, but that's what a mixture of experts is it's different levels, and it generates tokens based on that. A gated DeltaNet hybrid linear attention mechanism, and intact vision tower, so it's multimodal. It's been specifically obliterated. So what obliterated means is when you obliterate a model, there are certain safety gates that are put in place in models. What obliteration does is it goes in and it looks at those safety gates and it changes their values, right, for the vectors, so that the refusals happen much less. And there are pros and cons to this. One of the cons is that sometimes obliteration can be like a lobotomy on your model, and your model becomes dumber because of it, right? So you have to be careful about obliterated models. I was reading that this one's really good. So it maintains coherence and making it suitable for applications. So the refusal rate, which is crazy, right? So the original Qwen had an 85 to 87 refusal rate, and these are prompts that they put together. I don't know what the prompts are, but there are 100 prompts that they put together. Qwen was refusing 85 to 87 of them. Some of the models like Gemma or Llama or stuff like that will have like a 95 to a 97 refusal rate. They were able to take it from this down to like a 1 out of 100 refusal rate, which is kind of crazy. They verified zero collapses. So this is what I'm talking about with the kind of lobotomy, and So, and these scores, you can go look them up, but these are scores of how well the thinking works. So we can take a look at that. This is this again is a 32K context. This will be the last one we use in this one, and then we'll go into the big heavy hitters. If we take a look at this, right away, the first thing it didn't do was make the changes, right? I guess the last thing we'll say is, can you suggest the changes I should make to get rid of legacy forms controls, right? So that will be our last one. So the project already has an advanced adoption of signal-based forms. So the detailed store, picked that up. The text input and text area component, so it found those two. There's actually one more that Gemini found when we were using anti-gravity. Well, when I was using anti-gravity. There are currently no business components lagging behind. The project is already... You called out text input and text area. Let's see what happens if I ask it to suggest the changes that I should make. So I'm curious about that one. And while this is working, let's go ahead and we're going to grab this model. We're going to go here. We're going to manage models, and we're going to tell it to add another model. The model ID for this one is our obliterated model. We're going to call this one Quable. Quen plus Fable reasoning. $35 billion. And we're going to say it's got an A3B. That's the attention model. It's a 3 billion parameter attention model. The URL is this one. Actually, we're just going to take all of this, right? Because it does have vision. It does have tool calling. And we're going to do that. Cool. So there we go. So we've added our new model. And now let's see what Gemma says, right? Again, Gemma is a model that with the right plan is not going to cost you tokens. It's not going to cost you credits or anything like that. You should be able to work against it regularly. And so with the right harness, it should be a fairly powerful control. We need to move away from NG control and reactive forms model. So our text input component and text area component use a forwarding pattern. Yep. So here are the suggested changes. Update, inject NG controls or replace it. So this was our way of injecting that control. We created a wrapper around it. I forgot that we'd done that. Instead of injecting NG control, you will want to interact with the form field signal provided by the new Angular Signal Forms API. You can remove the dependency on reactive forms. So it's picking up that we need to make these changes. It's picked up some different stuff. Why do this? Great. Make suggested, or make the suggested fixes, right? So we want to make sure that we're prompting the same way. That's why I'm copying and pasting these, because when we run the next model, we're going to do the exact same thing. So I want to see what we get out of this. And I do have to end on time today with my wife and daughter traveling I got to take care of my younger daughter and make sure that the puppies aren't terrorizing each other. Well, the puppy isn't terrorizing. Um, I call them the puppies, but Indy is 4 years old. You know, she's fully grown, but she gets terrorized by poor little Sunny. So to keep her stress levels down and to teach Sunny that, hey, you can't just go chew on another dog. We spend a lot of time working with the two of them. And so I definitely need to end so that they aren't given free range. Sure, we'll allow it to run this. This is the first time that I've had a local tool try to run something. I'm okay with it running PNPM list. Hey, Ole, thanks for showing up, man. We'll see you next time. Next week, I'm not sure what I'm going to be doing. Yeah, we'll have something next week. No response was returned. So we're getting these interesting no response returned. I'm not sure what's causing the issues here. Because we got 4 to-dos. Read this. Read this, read this. So it's failing on this last one. I don't want to debug this too much. I want to focus more on the differences here. So we're going to pop over to a new chat. We're going to, instead of use this one, we're going to use Quable, right? And with our Quable, we're going to run the first prompt and just see what we get. One thing to be aware of with obliterated models is sometimes, oh. I'm going to try again. Yeah. Model not deployed. So it's saying that the model isn't deployed. And what that means, so I'm seeing that right here. What that means is that the model was deployed for a bit, but it's not deployed anymore. I do. Oh yeah, and it says it's cold here, right? So it hasn't been loaded, so it has to be loaded. It takes about an hour for that to happen. Interesting. So let's go grab one of the Quen models. So we could grab this one. We could grab the instruct. What I'm looking for. You know what? Let's run. Let's take the instruct model here. So we'll copy this one. We're gonna go here. We're gonna manage models. We're gonna add another model. So we'll add this one because it's warm. Yep. And we'll go ahead and grab all of this and add it here. We'll save that. So there's our instruct. I do want to see a Fable tuned model. So let's go ahead and get a new one here. Let's go ahead and copy that. We'll paste it here. Copy that, paste it here. And, oh, I didn't change my model. There we go. I was like, no, it was there. It was warm. I know it was warm. The last thing that I want to do at this level, and I don't want to spend too much time doing this, but let's grab this Fable 5 distilled. I'm very curious about this one. So from AutoTrust, using a LoRa on agentic coding traces from Fable 5. So basically what they did is they went out and they ran some Fable 5 stuff while it was still available. They ran some agentic traces on it. They created a LoRa out of it. A LoRa is the way of adjusting the weights. And so achieving a 92.7 human eval pass. So using this model, I'm very, very curious. How much different does it change our Gemma 31 using Fable? And yeah, like once you get into stuff like this, you start getting into the not family friendly language and stuff. So I'm not going to read some of the stuff that was there. It wants to run. So here's the interesting thing. It's trying to run a grep. Oh, actually, I do have grep installed. Never mind. It probably recognizes that I installed the tools to allow it to run grep. While it's doing that, let's go ahead and add in our new model. And so this one is going to be Gemma 4, Fable Distilled, great. So there we go. We've got that in place. And I just want to make sure. Yeah, it's a 32K. So we're going to start getting into some bigger models here after this one. But let's see the difference between that and our Quen, right? So between Gemma and Quen. The one thing I do want to call out between Gemma 4 and Quen is these are the base models. They haven't been trained on anything. So you can probably find Gemma 4 distillations that are better. And that's probably what the Fable will do. But so it's telling it's going to do it. It searched the overview. It reviewed 5 files. What are the 5 files? It reviewed the README, the project, and the package JSON. Perfect. Ran a grep. It recognized that I have grep installed. Usually you don't have grep on Windows, but Windows just added the core tools for Windows, and that adds grep and a whole bunch of other stuff, which was really awesome. So it picked up that we're using Nest 11.1, we're using Graph, we're using Prisma, we're using Postgres. That probably grabbed that from the README, or it could have grabbed it from the Prisma settings. It did pick up, so one of the things right off the bat that's interesting is Gemma said we're on Angular 17, but Quen, both at the 9 billion and at the 31 billion parameter models, picked out Angular correctly. It's picking out my versions correctly. It's picking out NX, it's picking out PNPM. It grabbed ESLint and Angular ESLint, and it grabbed that I'm using the CodeGen. Your product is very modern, so we're using Angular 22. Signal state management, we're using NGRX signals. Notice that it didn't grab component store. And it also said that we're using signals instead of the traditional store, which is very, very interesting that it called that out. Tailwind. So this is why I wanted to run Quable. I probably should have looked and gotten it up and warm before getting here. Very, very interesting. So it's doing some really, really good stuff here. Let's go ahead and grab this and just see what we get from it. So are there any components that could be changed to signal forms? So we're going to see what that gives us. The interesting thing about Qwen versus Gemma is Gemma took a long time to get to this point, right? Qwen jumps in right away. Unfortunately, we're having to compact the conversation. We could probably add some tools that would do this for us, right? But maybe that's something we could look at in the future. But today I wanted to just analyze, could we run like a local model? So yeah, we're chewing through context like crazy. So it's reading my different components. It picked up a sub-agent. That's fascinating. So we got a sub-agent that's looking at the edit dyno component already. Very fascinating. And it's reading through my stores. This is getting close to like Copilot-esque, which is crazy to me. Because I'll tell you guys right now, I'm paying $25 a month. If I could run a coding model that does decent for that price, where I'm not having to worry about like blowing my token budget or stuff like that, it makes it a lot more interesting for me to move away from the big models and into the smaller locally hosted models. And that has real implications with like the stuff I would do at work, where I would be like, yeah, we don't need to run this big generalized model. So based on my analysis, I can see the project has already been migrated to use signal forms. Areas for improvement. Looking at the Edos, I can see that it's already using that. So we're good there. Areas for improvement. Well, the forms simplify the effects. So this is interesting. It didn't pick up the two files that are using the old stuff. Oh, and it's having to compact the conversation in the middle of doing code. That's a little bit interesting. Yeah, the biggest issue here is not the model. The biggest issue I'm seeing is the context window. And that may be where going someplace else might be useful. But we'll see that there are other models that we can use. And you know what? We'll take a look at the changes that it's proposed proposing, it's bringing in an effect. Why is it bringing in an effect? This could just bind to the signal store, right? We need to fix this. Wait. So it removed the effect. Great. It picked it up because of my WTF comment. So interesting. So it removed the effect, which it did okay job of. I'm not sure how this works. Form validation with apply when and validate standard schema. Where did it do that? I don't think it did this. Preserve the form validation with apply when and validate standard schema. So it's asking would I like to we're gonna ignore its question. And we're gonna move on to the second one, right? Can you suggest changes I should make to get rid of legacy form controls? Local models for me were running way too slow. The reason the local models tend to run slow can be a bunch of different things. It can come down to your processor. It can come down to your memory type. If you're using GGUFs and your models are too big for your video card or your memory pool, then you can wind up with swapping, and that can get really, really slow. Oh, I don't have yeah, they're going to be really slow. Like on the order of 3 to 5 tokens per second. If I can fit a model entirely within my my laptop's graphics card, I can usually get between 15 and 30 tokens per second. And that difference really comes down to the density of the model and a bunch of other things. But at that rate, they're usable, right? Like the thing that's really interesting here is all the compaction that's taking place, right? Because we're right at the edge of our token limit. So it's having to keep compacting this discussion. But at the time, 8K is unbelievably, yeah. Well, 8K in any denomination, right, can be expensive. And like a Spark is a good and I've been debating building my own GPU box. So there are these boxes you can get that will put GPUs in them, and you can then split models across GPUs and stuff. And I was looking at getting a few, like the really good ones right now are the 3090s. They're difficult to come across because they have enough memory to run them. And yeah, to your point, I don't have that kind of money. Yeah, cost is going to increase. It has to increase. Especially as local models get better and better. Like that's a problem that these big companies have, right? Is the local models are as they get better and the general models stop being able to compete, we get into this weird situation where they have to make more money to make up their compute costs, but people are going to use them less because it costs more. So they have to keep raising. Like I agree with what you're saying. I think the peak of AI is at least 5 years away. Hot take. Since the internet boom was something like 10 years, and I don't know that that's that much of a hot take. it will be interesting to see what local models versus general models versus, you know, all this other stuff winds up doing. And what I think we're going to start seeing is we're going to start seeing these big companies employing, and they're talking about it now. They're calling them edge models and stuff like that, right? Because they recognize that they can't compete. Um, so yeah, so the edit dyno component, yeah, the add dyno component, the delete. See, it's not picking up the two components that everything else was. And so I'm curious about that. I thought in terms of when will my parents adopt AI? My parents are early 70s. That's about the same age as my parents. It's at least 3 to 5 years away. Yeah, I was talking to my mom about AI on vacation last week, and you know she gets the old person, you know, where they purse their lips and they're a little bit frustrated, and she's like, "You can't use AI. All the water the AI uses, and all this and all that." And like, great, yeah, I get that there are issues with it, and both sides have their points, and I think those will need to be worked out. But the reality of AI is it's here to stay, and it's disrupting a lot of the world. And how let's say that they're 100% correct that AIs are as damaging as everybody says, right? Let's give that fact. Let's say because of that fact, we outlaw AIs. Well, the power of AIs is going to convince other countries, right? Even if the US outlaws all AIs and all of Europe outlaws AIs, and right, like all of that stuff, there will still be people out there that are using AIs. Even people in the US will be using AIs, um, even doing it illicitly, right? So the reality is it's so transformative that people will be willing to do it illegally, or they'll live in places where it's not illegal to do it, right? And so we have to recognize that fact that that's a reality, and we have to figure out how it fits with within, you know, the current, you know, what we know to be true, um, is probably the best way to put it. Um, and we need to be very cognizant of the decisions that we're making and the trade-offs that are there. I am happy to see that we're picking up text input component now. But yeah. Um, it would have to be built so heavily into Google that they'd have no choice, right? Developers are in a prisoner's dilemma. I totally agree with you on that. Um, every every advancement that we make in AI is an advancement in us nearing the end, right? And maybe I can't see the future that well. Well, I know I can't see the future that well. Maybe there's something on the horizon that changes that. But for developers right now, there's a reality. Um, I read a Gartner report this morning as I was preparing for the stream that talks about the reality of, um, and we're probably going to skip the Fable one because this one's going slow, and I want to get into DeepSeek and GLM and potentially Kimi. Um, so um, but I definitely want to take a look at DeepSeek and GLM. Um, but yeah, the Gartner report that I got distracted by, or I got distracted in the middle of, was talking about people who are on unemployment and people who are laid off in the past year or past 2 years. Um, there's a disproportionate number of people being laid off represented in tech. There's a disproportionate number of people that are being laid off that were work from home, and there's a disproportionate number of people that were laid off that didn't use AI. When you look at the people who weren't work from home, who were using AI and stuff like that, their proportions fell in line with the industry as a whole. And so that's an interesting, very interesting take on the market right now. So the people who are being, and Gartner was looking at the US, right? Because they're a US firm. So in the US, if you're full-time work from home, you have a more than double chance of being hit by a layoff just based strictly on the numbers. If you're not using AI, then you have a more than double chance of being hit by a layoff, right? And so those two things impact us as developers, because who's more likely to seek full-time work from home? Well, high-skilled engineers, right? Who's more likely to be building AI? Well, high-skilled engineers. That lowers our risk of being laid off. But at the same time, we're building the tools that could make our chances for being laid off bigger, right? And so I totally agree with your prisoner's dilemma here. We are like at 20 to 30% usage tops right now. US would need a change of government, which won't happen for 2 years. I discovered the Consensus app, which is AI, but it uses research articles. Remote is because COVID is over. So yes, part of remote is because COVID is over. The other part of remote that is very, very interesting is like these cities discovered that when workers didn't return to the office, then workers didn't go eat lunch downtown, which meant the restaurants couldn't be open downtown, which meant that restaurants were starting to have to close because people may not want to drive into the city, right? And so there was an economic impact to the cities themselves. So the cities went to the big employers and they're like, hey, if you bring your workers back into the office, we'll give you tax breaks, right? And the employers are like, oh, free money, great. We'll take the tax breaks. So you're going back into the office because when you're in the office, you eat lunch. And when you eat lunch, you support the local businesses. The local businesses make downtown of your cities look better and more thriving and whatever, which is, directly reflected in tourism numbers and all. Like, I mean, there's a lot of reasons, but one of the big reasons is people are just getting money to bring you back into the office. You have these big office buildings that are sitting empty, and these companies that own them are like, well, why are we paying for them? So yeah. So let's see what it picked up, and then we'll skip over. I really don't want to skip over the Fable one, but did I add it already? Yeah. So it did a good job. I was watching it, right? So it picked up a whole bunch of stuff. I'm going to tell you right now that Qwen is a very, very capable model. And this is something that everybody knows, right? So the UI component libraries contains two components that use the legacy reactive forms, the text input and the text area. Perfect. So form components, we've got stuff using that. So it did a good job. Let's get a new one. We're gonna go. I just want to see if adding Fable to the Gemma 431B does anything. I prefer to be in the office, just not so much. I take a huge pay cut and have less interesting work. are using the smallest Qwen model. We started with the smallest Qwen model. So if you want to go back, well, not the smallest. We started with the 9 billion. The smallest Qwen is Qwen 3.5. I think it's a 7 billion parameter model. We started with Qwen 3.5.9, and it was pretty good. And I've run Qwen 3.5.9 locally with 144K context, which is pretty impressive. And it does a really good job. Like Qwen is pretty, like, it's pretty amazing. So with the Fable distillation added, we're already getting much better, right? Like the project overview, we still failed. We still got Angular 17. It is still saying we're using component store, which is wrong. NGRX signals. And I'm not sure that the Fable did much for us. Let's see something that it actually has to reason about. We'll try the component stuff. I actually just built a PR reviewer skill. I still have to fix how much context it uses. Yeah. Oy. So like, this is not good output, and I'm not sure what's causing the output. It could be the Fable distillation that caused that issue. Yeah, run sub agent. Like it's trying to run a sub agent, but it's stopping. It's not running that sub agent. So it sounds like the Fable has the ability to spawn subagents, but Gemma 4 can't understand the subagents, and so we're in this weird place. Great, that was a good experiment. Let's get into the bigger models, right? So I'm going to turn this off. We're just going to look at the most popular models right now. So we can see Qwithos, the 9 billion Claude Mythos on top of Qwen is a very popular model. But I want to take a look at this one, GLM 5.2. I want to take a look at DeepSeek 4 Pro. And we'll take a look at Kimi, maybe, if we have time. But Kimi, if we look at Kimi, we've got 256K context on this. And it's a 1 trillion parameter model, so 1,000 billion. If we look at DeepSeek Pro, we've got 256K context, and we've got 862 billion parameters. And GLM is the smallest of the three at 256K context and 753 billion parameters. In experiments with GLM, it'll be interesting to see. I've had it get stuck in loops, but let's add GLM 5.2 because it's the newest model. It's the one that's in the news. We'll get this one up and going. So we'll go ahead and we're going to add a model here. Our model is the GLM 5.2. This is GLM 5.2. We're going to get this. And we're going to leave the default. Well, actually, we can go bigger here. We can go 32K here on our output and our input tokens. So we've got 32K output, 256 minus 32. What does that wind up being? What is that? That's 224. Is that right? 56. Yep. So we're just doing really, really quick top of the head math, right? So there we go. We're going to get a new one. We're going to swap over to GLM 5.2. There we go. And let's see what GLM 5.2 thinks. Again, we've got the Angular skills added, but this is a much bigger model, right? In my case, I like remote work. There's probably too much traffic in my city. I live in Lima, Peru. I didn't realize you were in Peru. One reason I changed jobs was the traffic. Downtown Salt Lake is not fun, but I don't think it's quite on the level of Lima, Peru. I don't know. I don't enjoy going to the office. Like, there are parts about the office that I enjoy, but on the whole, I have my own office in my house. I can look out, and I can wear shorts any day I want in my own office. When I go into the office where I work, they want you, in pants and whatever. I'd much rather have shorts. But yeah, I don't know. I I can walk to the fridge and grab snacks that I like. I don't care if the company provides them or whatever. And there's a lot of benefits to just being in my own house. The PR reviewer finds bugs as well as maintenance issues. I wonder how many bugs we'd find just pointing it at the general code base. We could go fix them. You could so use like use a CLI harness and just use your PR reviewer skill. I pointed it at TBD Gamer's Liquid Sky and it found 2 bugs in his last PR. That's pretty cool. Like, I'm impressed with that. Very impressed. But if we look, like, GLM 5.2 is already off to the races and going. So it's a monorepo demo application for managing dinosaur data, CRUD. It showcases a complete full stack architecture. Boom, using Nest.js, GraphQL backend, and Postgres versus that. Yep. So it picked up NX22 as our mono repo. Picked that up. Angular 22 with standalone components. Picked that up. Yep. We're good there. Signals 21 and NGRX toolkit. Picked that one up. It's giving us our package structure. So UI components, custom RxJS utilities, key libraries used. So it's picking up all of these. So we get signals and NGRX operators. So it is picking up NGRX toolkit, and it is correctly picking up that we're using with mutations and Rx mutation. Perfect. Picks up Zod, picks up mutative. I think we still have JS Cutlery. Picking up our backend. It did pick up TypeScript, ESLint. How modern is it? Very modern. It's bleeding edge in several areas. As of the current date, this project is on the latest major versions of nearly every key dependency. So it's picking that up. Modern patterns in use standalone components. Signal-based state management. So with Signal store, no legacy, no NGRX store, no actions, reducers, or effects. We're using Tailwind, SWC compilation. So this is the first one that picked up the SWC change. ESLint flat config. Yep. Private fields. Yes, it's even picking up that we're using the native JS private fields and not the _ private keyword convention. That's pretty impressive. This is GLM 5.2. Volta for reproducible, yeah. Minor note, the README mentions Angular 21. Look at this. It's actually picking up some issues. But this is the state-of-the-art Angular. Perfect. So let's hit it with this one, right? Some more reasoning stuff for it to do. Are there any components that can be changed to signal forms components in the project? And this is the thing that's impressive is like, and this is where I think like Europe and the US needs to start worrying, is GLM is from, I think, Z.AI, which is a Chinese AI firm. DeepSeek is a Chinese AI firm. Kimi is a Chinese AI firm. And we can get these models for fairly cheap. I don't know if that's because they're being subsidized by the Chinese government in some way, but we can get access to these massive context windows these impressive models, and they're super cheap. Like, I have no token limit. When we look at, as this is working, when we look at this, the concurrency cost is 4. That means I can only run one GLM52 at a time, but that's okay. I rarely run multiple agents at the same time anyway. Right? It's a 753 billion parameter model. Granted, it's quantized to FP8, but it's still doing an amazing job. And at 256K context, it's really good. So yeah, I don't know. And like, if we look at the other models out there, we'll compare. We'll probably compare DeepSeek, and then I'm going to have to end. So let me look at the form. So it's still digging through it, right? Like, it's picking up that. Oh, there we go. There we go. It actually picked up the one that everything is missed so far, and I'm curious to see the output on this. Toggle component. This toggle component is it's not using, oh, it is using a form field. Never mind. I guess our toggle component was changed over. So really the text input, but one of the first things we can see right away is we gave it 32K output and 256K, right, out of our 256K tokens. We haven't had to compact at all yet. And this is bigger. This is a bigger context window than we typically get by default. By default, it usually sets up 144K context window. I wanted to go for the full context window on this. But with a model like this and this much context, you could do some really impressive stuff. On some of these models, like if you run a Qwen 9 locally, you could get up to 1 million context, which is crazy. It's 4 times the context of what we're doing here. And it's much more context than most of the models give you when you set them up. What's exported in UI components? So it's looking at this. It created a memory file. Interesting. So it's creating a file to help it remember stuff. Oh, this is cool. This is very cool. So here we go. I searched the code base for all formulated patterns. Here's what I found. So the edit dyno component, toggle component, and add dyno component. The main form is already fully integrated with signal forms and Zod, still on legacy forms, reactive and ng control. So the text input component, this is correct. So this is correct. Same legacy pattern as text input. So we're using reactive forms. Inject control depends on form control directive. And the no-op value accessor. Key findings, legacy components are dead code. This is not true. They are used. Well, maybe they are dead. So it's already picking up the text input and text area, which is what we want. The other two reactive forms are dead code. They're not used anywhere. They're candidates for deletion rather than migration. They should be rewritten to follow the same pattern. Great. So right away, and I want to jump over to DeepSeek to just see what we got. But right away, we can see that GLM 5.2 is a very capable model. It turns into a very powerful agent when added to the Angular skills and, like VS Code or something like that. So very, very capable model. Let's grab the last one that we're going to look at today. We're going to take a look at DeepSeek. It's slightly bigger. Has the same it has the same size to it. So let's go ahead and add this one in. So this is our DeepSeek model. And you can see that these are provided from the organization themselves, ZAI.org, and this is DeepSeek. The name here, we're just going to call this DeepSeek Pro. The URL, we're going to use the same URL, and we're going to use all the same stuff here. So we're going to get a much bigger context window and all of that stuff. So there we go. Let's get our new prompt and let's see what we get, right? Like, how does DeepSeek compare? GLM, in my own personal testing, I think GLM is probably my favorite model, even though it's the smaller of the bigger modern ones. So it's thinking about stuff, it's reading the appropriate files, right? So DeepSeek has already decided that it has enough context. So it's CRUD, it showcases a modern full stack, NX, yep. So NX, that, backend, that, Angular 22. So very, very similar to what we got with GLM here. Page package layout, great. Interesting. It read schema.prisma and it gave us, the dinosaur model ID and name. Name must be unique. So it's giving us a whole bunch of stuff here about the data model itself, giving us interesting key libraries. Again, very modern, bleeding edge at several areas as of the current date. So it's picking this stuff up. So it's using NGRX signals exclusively. Signal stores with composable features like with state, with call state, with errors, with mutations, ARGs, mutations. This is a modern NGRX recommendation, moving away from the older NGRX store and effects. Also demonstrated, that's where we keep getting the component store, is that the README still talks about it. One legacy area worth noting, the front end still imports Angular forms, the template driven. So look at this, it's already calling out that, hey, you're using the template driven forms, you could be using signal forms. So perfect. So DeepSeek is already ahead of the game. So we're going to say, hey, are there any components that can be changed to signal forms components in the project? Again, I'm intentionally being vague here because I want to see, how capable are these models that are not the big, the big three, right? OpenAI, Google, or Anthropic. I guess we could put Grok in there too. I really haven't done coding with Grok, so I can't tell you a lot about it and why I don't consider it that often. But if anybody else has done Grok, I'd be curious to hear about your experience. I think it would be interesting to take a look at that. So it's already exploring again. like I find DeepSeek to be a very capable reasoning model. The only downside to DeepSeek and GLM that I've found so far is like during high usage hours, they can run into like, you know, the GPU is overloaded errors or different things like that that tell you that there are a lot of people using them. Um, but for the most part, I actually find these to be highly capable models. So it's looking for form, group, form control. Like it's looking for all of this stuff based on the old, um, and it's looking for stuff in the templates. It knows to look in TypeScript files for these and the templates for these. That means it's using the Angular skills and it's determining what, you know, what goes there. So doing some more searching, like this is the kind of stuff that you'll see um, as you're working through code bases. We use Copilot a lot. I used to use like Claude Opus almost exclusively, and then Claude Opus became 15 times more expensive, and now I wind up using Codex um, or you know, one of the Copilot models quite a bit more now. This is very similar to what you'd see from one of those models. Um, I'm not seeing um, I'm not seeing a lot of benefit to running a bigger model. Um, and this is where I think the bigger models are getting into trouble. Like it's already zeroed in on the text area and the text input and the inject ng controls. Um, and it's using the memory that it created with the signal forms audit. That's cool. I have a prior audit in memory. Let me verify the current state of the controls by examining the actual components in the edit dyno. The audit is confirmed. Um, so it's already, I'm going to tell you right now, I'm impressed by DeepSeek here. And here's the crazy thing. If you're on a plan like Featherless, again, I'm not trying to advertise Featherless. They don't pay me. This is not an advertisement for them. But for like 25 bucks a month, I could swap between GLM and DeepSeek all I wanted. And the other thing is, if I created my own harness that allowed me to swap between DeepSeek and GLM based on the types, and I could get a very, very powerful tool. Can you paste images? With DeepSeek, let me take a look. I don't know if DeepSeek's text generation only, so no. Does GLM do vision? No, text generation only. So with GLM and DeepSeek, you can't. Kimi is the other big one, and Kimi has a vision model. So with Kimi, you could do images. So, I mean, this is the biggest model, and maybe we'll come back and take a look at Kimi. But yeah, you can absolutely do images with Kimi. So something to be aware of. But there, I mean, when you look at this, these are the most popular models, right? Like GLM 5.2 is the most popular model right now, followed by the Quithos. Okay, not an advertisement for these people, right? So the reason I'm on Featherless is it's flat pricing with unlimited tokens. So for $10 a month, you can access models up to 15 billion parameters. You can have up to 2 concurrent connections and up to 16K of context, right? At $25 a month, this is what I'm paying. you get access to DeepSeek, Kimi, and GLM. Access to any model, so they don't limit your size on any of the models. You can have up to 4 concurrent connections, and you can have up to 32K context. But with DeepSeek, Kimi, and GLM, you get 256. Then you start getting into the more expensive stuff. If I was doing more agent stuff, I may look at this plan, but this is really expensive for what I do. But like, you can get 256K context at this plan. So you're getting unlimited tokens. You get 256 context. You get an agent runtime. What an agent runtime means is that they'll run an actual agent on their servers for you. So if you want to run some special agent and you don't want to set up the Docker containers and all of that, they've got all of these agents and stuff. And everything's sandboxed, and you get persistent storage. So this is a big step up from where I am, but it's really hard for me to make that jump. And then at 2,000, now you're up to 8 concurrent. There's no limit on sizes to models. So yeah, there's a lot of benefits. Yeah, I looked at open code also. There's a lot of people out there with stuff like that, right? There are a lot, and that's why I don't want this to be an advertisement. This is what I use, and the reason it's featuring is because I use it. I have a plan on it, and yeah, for $10, and it looks like a good backup. Yeah, like you're saying opencode.go. I haven't looked at that one. Opencode.go. So yeah, if we look, so it looks like you can get with their plan, you can get GLM, you can get Qwen 3.7, Kimi, you can get Mimo, DeepSeek. Like, these are all big heavy hitters. 5 requests per hour. Yeah, so their usage plan is interesting. The reason that I like what I've got is that it's unlimited. Yeah. I like that it's unlimited because I do a lot of silly stuff with agents. Yeah, I honestly, if you guys find something that works for you, there's OpenRouter, there's Featherless, there's OpenCode.go, I don't know, there's a whole bunch of them out there. I'm not saying you guys should use Featherless. I'm not saying you should use OpenRouter. I'm not saying you should use OpenCode. Go find the one that works for you and fits in your budget and works for what you want to do. What I am saying is if you can get access to these models, GLM, DeepSeek, and Kimi, you're gonna be impressed by what you can get, right? So like you can see here that it found my text input component, my text area component. Again, it's saying that these are dead code, so we might want to take a look at that in the future. Oh, this is GLM5. Wait, did I not swap over? I didn't swap over for DeepSeek. I've got to end. When we come back, we'll take a look at DeepSeek and Kimi next week. You never hit the limit on the Go plan. That's good to know, Ole. I burn through tons of tokens. I've got a bunch of agents that do different things, and we can talk about that kind of stuff too. One thing we'll come back and we'll take a look at the. I want to take a look at DeepSeek. I thought we were looking at DeepSeek. We were looking at GLM 5.2 in a different chat, but let's take a look at GLM 5.2. Let's take a look at DeepSeek. Actually, no, we were still looking at Deep. Anyway, we'll take a look at DeepSeek. We'll take a look at Kimi, and you guys tell me. If you guys want to message me or anything, let me know if there are any models you want to take a look at next week, or we can go deeper into the bigger models. I don't code that much at work. When these are all my personal models, so I use this for my personal stuff. I do a lot of agentic stuff personally. And I'm happy to talk about that with you guys. I do have to end now, but we will see you guys next week. We'll dig into DeepSeek. We'll dig into Kimi. We'll take a look at pasting images from Kimi. It might be interesting to get like an error message and paste it in and see if Kimi can pick it up. It would be interesting to compare GLM 5.2 with GPT or Claude, for example. Sounds good. We can do that. I've got Gemini with anti-gravity. I'm not paying for any models, so we'll see what we can do. But the only model I'm paying for right now is Gemini, and that's because we've got a family plan for a bunch of other stuff with Google. But I've dropped all of my subscriptions to Claude. They're just too expensive, and especially when I can use like DeepSeek or GLM. So yeah, I've got to end. Thank you guys. You guys have a great rest of your weekend. We'll see you guys next week. And yeah, take care.